All right, and away we go. So now that we've discussed terminology, we are going to start looking at some of these examples and try to sketch these all on our own. So this is what we're going to get. They're going to give us a big pile of words. So this whole thing right up here, there should be enough information in this for us to draw something that resembles some kind of a function here, okay? And so now what we're going to do is we are going to go through this and we're going to decode this and pull out the information that we need so that we can start sketching this. So it says, use the given key features to sketch a linear graph. All right, that's the first piece of information is linear. This thing's linear, right? So if this is linear, this means, right, that the first thing we know is that this is going to be a single straight line, okay? Because that's a definition of what makes a graph linear, okay? So now that we know that, right, that we're doing a single straight line, that helps us, right? So we're not going to have any curves or anything like that. So we have no curves, all right? I switched my cursor style here so it's not so chunky. Okay, now, second piece of information. The y-intercept is -70. Okay, so now I know where this thing is crossing the y-axis. This is my y-axis right here. This is my x-axis, right? So if the y-intercept, right, is -70, that's good to know because now we are going to figure out how to label this thing. Okay. And I wish it didn't make me keep changing the thickness every time I want to do this. So if it's -70, it looks like I should probably label this thing by tens, right? So I'm going to make that -10. We'll make this -30, -50, and -70 is right here. And I know it's crossing the y-intercept here. Okay. Well, that's good. All right. If we're going by tens that way, that means this is 10. 30, 50, we'll just kind of leave that like that. Now it says the function is positive for x is less than -30. So if we're talking about -30s and stuff like that, then I think we're going to also go by tens again. So I'll make this will be -10, -20, -30, -40. I'm not writing it on each one because that starts to get kind of messy. Right? So every line represents 10, right? So this is how we're labeling our graph. And it says if it's positive for x is less than -30. That means after -30, which is right here, this thing is going up, okay? So what that means, okay, what that means, and this is the part that people struggle with, but what that means is that it has a y-intercept at -30. So I know it's crossing right here. All right, now, what do you guys remember about one of the main features of linear functions? Well, one of the great main features of linear functions is that you can draw them with only 2 points. That's all you need. You only need 2 points to draw a linear function. And so if that's what I'm going to do, okay, then that means I'm going to be able to draw something. With just the 2 points I have. And I have 2 points. I've got this and I've got this, right? So if it says the function is decreasing for all values of x, so that means that the slope is going to be negative. That's what that means. It means the slope is less than 0, all right? So it's going to be a negative slope, meaning that it's going down from left to right, right? Left to right, going down, all right? Well, with my 2 points, if I go here and I draw a line through there, that will give me that, right? And then it tells me my end behavior. It says as x approaches infinity, f of x will approach -infinity, and as x approaches -infinity, f of x will approach infinity. Well, let's try drawing this line here. Okay, so I'm going to go, that is not looking good here. Why is this going like that? This is not going well. Let's try this again, guys. My sketching ability is pretty terrible. All right, and so this is my line here, right? And I'm going to put this here. I'm going to put this here, right? And that's my quote unquote straight line, right? And so, oh, you know what? I just realized something, guys. Now I know how to. I just figured out how to do this. I'm going to use this thing right here, okay? And we're going to go like that, okay? And we'll put that on both of them. All right, so check this out. This should work. All right, so we got this, and it's going here. It goes through 70, right? And that's my line. Now we should be able to take this and move it somewhat, right? We'll see. Well, anyway, it should go through these 2 points, right? So that's how this works right here, right? It goes through this point right here, and it goes through this point. It's a little off, but you get the idea. Now, does this match up with everything? Well, it is decreasing. Slope's going down as x approaches infinity. So as it's going this way, so this is going down, which is what this means. So yeah, it meets that. And then as x approaches negative infinity, in other words, as it goes this way, f of x, which is your y values, approaches infinity, which means it's going up, right? So that's good. I like that. That works for us, right? So we now have a line that meets all the criteria. My y-intercept's negative 70. There's my negative 70. My it's got an x-intercept of negative 30, and the reason I know it's an x-intercept is because it says it's positive after negative 30, right? The function is positive for x is less than negative 30, right? So that means anything to the left of that, right? And then those two values gave me enough to do it, and then I made sure it corresponded with everything else, and it does. So that's how you know you're on the right track, okay? All right, let's try one more. All right. Now, it says here, sketch a nonlinear graph, right? Use the given key features to sketch a nonlinear graph. All right, that means that this thing is going to either be curved or, you know, pieced, right? One or the other. Well, the y-intercept is -5. It looks like we can use, you know, regular numbering for this one, all right? So -5 is going to put me at, this is 0, we got -2, -4, -5, y-intercept, so it crosses right there. Sweet. The function is continuous. That means it doesn't stop. It doesn't have any breaks in it. And yeah, so it's not discrete. The function is positive. All right, now remember, when we're seeing something that's positive or negative, that means we're talking about an x-intercept, right? The function is positive for x is less than -3. That means I have an x-intercept at -3. And at x is greater than 4. So go 1, 2, 3, 4 over. So here's some intercepts here. And if it's positive less than -3, that means that it's above. Like after this point right here, going this way, it's above, right? And at x is greater than -4. So over here, once we get to this point, it's above, which means that from this point to this point, right? So from that whole point, this thing is below the axis here. So I'm starting to get an idea about what's going on here, right? Okay, now it tells me that the function has a minimum. Ooh, we remember minimum and maxima, right? The function has a minimum at 2, -6. Well, let's find where 2 is, right? 2 is over here, and -6 is 1, 2, 3, 4, 5, 6 is right here, okay? And then it says the function is increasing for x is greater than 2. So that means that after this point right here that I just sketched, this thing is going up. The slope is up, right? And I know it's nonlinear, so it's going to be a curve. So it's going to be something that sort of goes like this and sort of curves, right? And it could curve this way, or it could curve up a little differently, right? But it gives you a little bit of leeway there, but there is a bit of a curve in it, and you want to try and represent that to the best of your ability. Like I always complain about how hard it is to use this smart book stuff, right? But it's hard to draw these, right? And then it says, as x is greater than, as x is heading towards infinity, as it's approaching infinity, f of x is approaching infinity. Well, that's kind of what I got going on here. And as x is approaching negative infinity, so going the other way, if I continue to graph this around, right? And so if I go like this, I go around, this thing is curved, right? So we're going to just kind of, so it looks kind of like a sort of weird parabola, right? And as x is approaching negative infinity, in other words, as this is going this way, f of x is also approaching positive infinity, just like on this side. So this graph works, right? It only has one minimum, right? It doesn't have any relative maxima or anything, so I know it's not going to do, anything funky between these two parts, right? So it matches all of the criteria listed, and we've got something that basically looks kind of like a lopsided parabola. So we will take it, and that is your function with this. All right. So I'm going to stop the vid, and then the next video is going to cover the next examples.